Right, okay, this is going to be looking at question 2 of the June 2014 FP1 paper. Let's have a read of the question. So we're given this function, f of x is equal to x cubed minus 5 all over 2 times x to the power 3 over 2 plus 2x minus 3, and we're given the restriction that x has got to be greater than 0. Seeing as you are further maths students, it's worth sort of talking very briefly about this restriction here, x is greater than 0. X is less than 0, not going to cause us too much an issue. We just restrict the domain to being greater than 0. But when x is equal to 0, notice what happens to this fraction here. This denominator will become sub in 0 here, so this whole denominator becomes 0, so it's going to be 5 over 0, which is infinity. Okay, so basically we're going to end up with an asymptote when x equals 0. Not a huge issue, but that's one of the reasons why they've restricted the domain to being x greater than 0. Okay, so the question asks, show that the equation f of x equals 0 has a root alpha in the interval, it's a closed interval, from 1.1 to 1.5. This is a nice, easy question. It's worth 2 marks. Nice, easy, bread and butter marks. All you have to do is substitute in the lower bound, 1.1, into this function. And you'd have to substitute the higher bound, 1.5, into this function. Okay, find out what they come out as, and then it should be pretty clear that there is a root, normally because one's negative and one's positive, but we'll talk about that when we get to it. So, just like Blue Peter, here's what I've written out earlier. Here is how you would write it into, this is how you type it into a calculator. Okay, so when x equals 1.1, you just simply replace x by 1.1, and when x equals 1.5, just simply replace x by 1.5. Tip is when you're using a calculator and evaluating something quite long like this, it's really easy to make mistakes. Okay, order of operations sometimes get confused. Okay, best thing I can give you is use brackets. If you think that a bracket should be there but you're not really sure, put it in anyway. There's no harm whatsoever. So let's calculate this. Let me just get the calculator up. If this is going to work for me, there we go. Right. Let's pull the calculator up. Now this is a calculator which is just part of this operating system. You'd obviously have a calculator in front of you in the exam that you know how to use and you're fairly familiar with anyway. Okay, so let's evaluate x equals 1.1. So we do open brackets 1.1, close brackets, to the power, now that's my power button, to the power of 3, minus. Then we do 5 divided by, and we want it all to be divided by, not just a little bit, not just the 2 which is divided by. So open brackets 2 times, open another brackets because we're going to sub in 1.1, close brackets, going to do it to the power of, 3 over 2, so open power brackets to do the power 3 divided by 2, close the brackets, and we want to close the whole denominator brackets there. Okay, and then we've got a little bit on the end, so we want to add 2 times, open brackets, going to do 1.1 again, and then we're going to take away 3 from all of that. And that gives us the answer, minus 1.635960430, etc., etc., etc. Okay, now in the exam, on the mark scheme at least, they say give it to 2 significant figures. As a general rule of thumb, always give it to 3 significant figures, okay? Because the mark scheme will ask for 2 significant figures, so if you give it to 3 significant figures, they can't complain, okay? If you give it more accurate than what they're asking for, they give you the marks. If you give it less accurate than what they're asking for, they won't give you the marks, okay? So, f of 1.1, going to work. There we go. So f of 1.1 is equal to negative 1.63. Okay, that's fine. Then we do exactly the same thing for f1.5. I'm not going to waste your time by inputting in the calculator. It's exactly the same thing, except whenever you saw me type in 1.1, you just type in 1.5, okay? And that should come out as 2.01. Okay, so what's actually going on here? If I just push this up there, that should be okay. So if you draw the graph, I'm just going to draw apart the graph. Okay, and we've got an x cubed graph, so it's going to look something like that. Not the best representation, I know, but it'll do. So this is our x-axis, this is our f of x-axis. And basically we're saying, well, okay, when x equals 1.1, let's say 1.1's over here somewhere, it's going to equal a negative number. So it's going to equal something like So it's going to equal negative 1.63. It looks something like this. Okay, it's not the best drawing, as I say, but you kind of get the idea. So 1.1 corresponds to negative 1.63, and 1.5 corresponds to something up here, 2.01. Yeah, definitely not the best graph whatsoever. But you kind of get the idea. The point is that 1.5 corresponds to a positive f value, and 1.1 corresponds to a negative f value. Okay, so basically what you're saying is this function is continuous. Okay, which basically means that it's unbroken between these 2 points, at least anyway. And so you can see that it goes from negative when x equals 1.1 to positive when x equals 1.5. So therefore, there must be a root. Now remember, a root is where it crosses the x-axis. In other words, when f of x equals 0. Okay, and you can clearly see there is a point where it does cross the x-axis, where f of x is equal to 0. And that point does lie between 1.1 and 1.5. So you get 1 mark for evaluating this. Oh, by the way, if you evaluate this, even if you get one slightly out, say for example if this was a 2 instead of a 3, they'll still give the mark, as long as one of them is correct. Okay, they do allow for a little bit of an error. Obviously they're both ridiculously wrong, then they won't give you the mark. Okay, you have to be able to, especially at your level, you have to be able to put numbers into a calculator. Okay, so the final marks, 2 marks, remember, the next mark is going to be given by basically summing up exactly what I've said with this graph here. So you can just say by sign change, or you can say that 0 lies between 1.63 and 2.01. That's absolutely fine. Okay, they're both saying exactly the same thing, sign change, or that 0 lies between those two things. Then 1.1, the alpha must lie between 1.1 or 1.5, or you can say, right, all here, or alpha is a root which lies between 1.1 and 1.5. Okay, basically saying that there's a number, let's call it alpha, which corresponds to a root. Okay, which will lie between 1.1 and 1.5, and that's pretty clear to see from the graph. If you say those two things, you get 2 marks.